Hello and welcome to part 3 for our correlation and regression video. After looking at it a little bit more, I'll post the whole PowerPoint, but for regression I just want you to really know that regression describes the relationship in the data with a line that predicts the average change in y per unit of x. The best fitting line is found by minimizing the sum of the squared residuals as shown in this figure. So we're going to go through the first couple slides here of regression, and I really just want you to know that the regression describes the relationship in the data with the line that predicts the average change in y per unit of x, and that's what we're calculating. After that, when we get to inference and confidence intervals and the t-test of the slope confidence, we're not going to get into all that. I mostly want you to know what regression is and states and how we calculate it, and then from there, when we go into correlation, the R value and how to calculate R. Everything after that point, I'll leave the slides up for you to look at, but it's not necessary to know, and then I will get another video up going over some of the homework problems for the week that go into a little bit more detail. So with this, we're trying to predict the average change in y per unit of x. Here's our fitted regression line with the residuals of smoking and lung cancer, the same problem we've been going through. So we're finding our data points, and here's our line that we for our correlation, and we're trying to find the average distance between each point and the line. So the regression line equation is the predicted value of y equaling a plus bx, where a is the intercept of the line and b is the slope of the line. To calculate a and b, b is equal to the r times the standard deviation of y divided by the standard deviation x. The intercept of a equals y hat minus b times x, not y hat, I'm sorry, y bar minus bx bar. So a little bit more illustrated example where b, here's the slope and change in y per units of x, b where x is 1 unit found on the x-axis, and a is the intercept at what point it crosses over, where we have our predicted value of y equaling a plus bx for our line. So this is how we calculate our regression. Once again, you can put this in SPSS and get it to pop out. Put all the numbers together, where we have our average value for x and our y bar and our standard deviation of x, standard deviation of y, and our r value. Plug those numbers into the equation for b, and we get a value of 0.02283. Plug the values in to get our a, and we get 6.77. So our predicted value y is going to be equal to 6.77 plus 0.0228 times x, and that's how we determine the line that predicts the average change in y per units of egress, which is how we started off with getting our regression model started. Once again, here's the output from SPSS. Here you get where you have your b, your standard error, and your beta standardized coefficients, your t-value, and your significance of it. Moving on, this is inference. But like I said, we're not going to go into inference. But please feel free to look at all the slides going ahead. But for all intents and purposes, for the class, I believe that if you understand correlation and determining your R value and the strength of association between -1 and 1 and what an R value states, moving into regression, knowing that it's the relationship in the data with a line that predicts the average change in y per unit of x, calculated with this calculation, and then knowing what it stands for, I think is where we stand for knowing correlation and regression. So know that stuff. I'll try to get another video going over some of the more detailed homework problems coming up soon. I'll see you in the next video.